Okay, thank you. Yan, so nag-resume recording na. Good afternoon, guys. Sorry for being late. Ayan, nabisit lang ako sa meeting. So, sorry ulit, nag-rant ako. Anyway, recap tayo sa mga nagaganap. Chapter 7. Anong Chapter 7? Chapter 7, tinignan natin ano mangyayari kapag binago mo yung electric field and magnetic field. So, pag nagbabago sila through time, may nangyayari something, okay? So, si Maxwell, ginawa niya, inayos niya yung mga equations para ma-account dun sa change ng mga to. Okay? So, we have that. And then, nag-proceed tayo sa chapter 8 kung saan chapter 8 ay yung diniscuss lang natin sa chapter 8 ay yung pointing vector. Itong pointing vector na to describes the energy that leaks out of the system. Okay. Ang ganda-ganda nung chapter 8. No? Well, at least for me. Bakit? Ano ba nangyayari sa chapter 8? Tingnan yung Sige, kaya ko to. Ito pala yung pointing vector. Ito yung di ba, discussion natin sa pointing vector and tignan nyo. Kasi intuitively, yung total work done is already this guy. Diba? Total work done would be yung electric field and magnetic field mo, E squared plus D squared, something like that. However, pag kinuha mo yung power, dW over dt, ang i-expect mo, i-dW dt mo lang to, diba? So, ito yung dW over dt. Pero, magically, may lumalabas na nagli-leak na power sa surface in question. Okay. So, yung nagli-leak na yan, amazing. So, siya yung pointing vector. So, ideally, ang intuitively, isipin mo, ito lang, di ba? Yung sinasabi ko. Kasi, ito lang yung total work, eh. Pero, ayan. Yung pointing vector. And nakita nga natin, pag in-apply natin siya sa mga wires, ayun yung P is equal to VI na nararamdaman mo. Okay. Yung heat na lumalabas dun sa system mo. Amazing. Then tumuloy tayo sa what happens to your waves, to your electric field and magnetic field now that we know that they are waves guided by the wave equation. Ano mangyayari pag nag-pass through yung mga waves na yun sa materials mo? So una natin would be the wire. Tinignan natin ano mangyayari yung string pala. So maganda yung string. Okay, so tinignan natin paano dadalo yung wave sa string. And napansin natin kapag may incident wave tayo, may babalik at may matatransmit. Okay, so yung mga yun, then kukunin natin at the end, kukunin mo yung reflection and transmission coefficients para malaman mo how much yung lumalabas, how much yung binabalik. Okay, so yun, diniscuss natin last time. Okay, now, for our lesson, next, balik tayo sa, sa problem natin na paano kumuha ng electric field at magnetic field. Okay. Di ba, usually, we know that, pag kukuha tayo ng electric field, pag alam natin potential, alam natin electric field. Pag alam natin scalar potential, which is a harder way, malalaman natin yung magnetic field. Okay. Sa electrostatics, Ross, paano natin define yung potential ng electric field?
Sir, yun po ba yung E.dl?
Oo, E.dl, di ba? E.dl. Integral nito, ayun yung negative integral potential. Okay? So, saan to nag-arise? Saan nanggaling to? Di ba may ginawa tayo? Di ba nung unang mga lessons natin, ginawa natin yung divergence and curl ng electric field. Okay? And nalaman natin na yung divergence ng electric field would give rise to your Gauss's law na pinadali niya ng sobra-sobra yung buhay natin. Then yung curl ng electric field, napansin natin na zero siya. Zero siya, di ba? Kaya nabuo natin tong equation na to. Okay? However, ano yung nasa right-hand side nito, Amina? Ano yung nasa right-hand side nito nung the past few lessons? Ano yung ginawa ni Faraday para lumabas yung nasa right-hand side? Ay, parang wala si Amina. Kazumi, nandiyan ka ba?
Yes po.
Ano yung nasa right-hand side nito? Ano yung nakalagay dito?
Kay Faraday na po.
Ah.
Yan po ba yung yung sa partial B, partial P?
Galing. Okay. Napansin natin na inayos ni Maxwell yung mga experimental result ni Faraday and lumabas itong equation na to. Okay, it makes sense naman no, na sa una nating mga topics, wala kasing change sa B. So nag-zero out lang siya. And therefore, we can use this definition to find the potential and therefore find the electric field. However, ngayon may problem tayo kasi may extra term na nga pala tayo dito sa right-hand side mo. So how do we fix that? Okay, so ayan. Recall yung Maxwell's equations natin. Okay, alam natin yung 1 and 2. That's given. Then, inayos yung 3 and 4. This is their displacement current. And then, this is your change in flux. Di ba? Change na magnetic field. Now, what we, may nabago ba dun sa number 2 natin? Okay, so walang nagbago sa number 2 natin and therefore, we can still use this equation. Diba? However, the second one, sa electric field natin, sa the third one pala, may nagbago. Since hindi na to zero, therefore, we should fix things. Okay? Now, alam natin na pwede pa rin natin isulat si B as this guy. So we could plug in. We have del cross E. The curl of E must be equal to negative partial T, and then del cross A. Tama ba? And therefore, I can further write this down as del cross, negative del cross, partial of A, partial of T. Pwede pumasok yung integral, no? Kasi ito ay time-dependent derivative. Tapos ito ay space derivative to. So, ito ay depende lang sa coordinate systems mo. Okay? And then, pagsamahin na natin yung mga curve dahil linear naman yung properties niya, pwede mong i-sum lang. So, lipat natin on the left-hand side lahat. We obtain that del cross E plus partial of A over partial of T, and this is equal to your 0. Diba? Kasi nilipat na natin lahat. Okay. Now, we have this guy. Vector yan, sorry. Okay, we have this guy. And we know that when we have this equation, di ba, dati nga, ganito, we have this, and this results to your E, defined as the negative gradient of some potential. Okay? Therefore, if ipaparallel mo to, we have E plus A, E must be equal to some negative gradient of potential. Tama ba? Now, we have your general formula for E. So, that is the gradient of V. Then, may contribution na ngayon yung scalar potential mo. So, yes, useful ang scalar potential. Okay? Ayan. So now we have this equation. It's nice, no, na, okay, hanapin mo yung potential, then hanapin mo yung scalar potential, you get E. Alright? Then from A, then, makukuha mo yung B. Okay, now, number 2 and number 3 is satisfied. However, may kailangan pa tayong dalawang i-check. Okay? So, 1 and 4, kailangan natin ma-check kung tama ba tong modification na ginawa natin kay E. Okay? So, dapat ma-check natin to kung it will fit sa Maxwell's equations. Kasi pag hindi nag-fit sa Maxwell's equations, hindi mo siya pwedeng gamitin. Hindi siya field. Okay? Hindi siya real world electric at magnetic field. Okay? So, we plug in this boy sa 1 and 4 mo. Okay? So 1, madali yung mangyayari kasi yung divergence ng gradient would be a Laplacian. You have this. Then, divergence ng A, papasok lang doon sa derivative with time. And then, of course, the right-hand side will not be bothered. Tama? So, wala naman, di ba? Pinlagin mo lang naman yung E. Okay. We have that. And then, sa number 4, pa-plug in mo yung B and E para maging in terms of potential lang lahat. Okay, so pag pinlagin yun, tinry nyo, gawin by hand, ito yung lalabas. Okay, mag-ano ka, do-double curl ka, so gagamitan mo siya ng product rules mo kasi del cross B, di ba? Magiging del cross A, and then nasa likod to ng libro nyo, if you're gonna do this, lalabas tong equation. Okay, so we have these equations, and if we satisfy this, therefore, valid yung magagamit natin mga A, and etc. However, tingnan nyo to, ang pangit, di ba? Yeah. Ang daming nangyayari, may divergence ka, may derivative ka with time, meron kang Laplacian. So, how do you solve this? Di ba? Napaka-komplikado. Given ka kunyari ng rho, how do you solve for this? And that's too complicated. On this one din, meron kang current kunyari na J, then how the hell would you solve for A and the potential V? Di ba? Napaka chaotic nitong equation. Di ba? So parang napaka hassle lang ito sa buhay pag gagamitin. Okay. However, yung mga galing natin mathematician, ayusin nila mamaya. Okay, so titingnan natin mamaya kung ano mangyayari. Okay? For now, let's try an example on how you would make use of this bagong definition ng electric field. Okay? So example, find the charge and current distributions that would give rise to the potential V is equal to 0 and A is equal to 0 whenever X is greater than Ct. C is the speed of light, T is a time. Okay? So whenever X is less than Ct, dun lang siya may value. And where K is a constant. Okay. Constant lang yung K, some constant. And then yung definition ng speed of light. Okay, we have this. Now, what we're gonna do? Kunin mo yung electric field mo, tsaka given ka ng V, given ka ng A, pwede mong kunin yung electric field mo and magnetic field. Tama ba? And then from the electric field and magnetic field, pwede mong gawin to. Kunin mo yung divergence niya. Makuha mo yung charge distribution. Nakuha mo yung B, kunin mo yung curl nun, baka makuha mo yung J. Okay, so ayun yung problem kasi, di ba? Kailangan mo lang makuha yung charge and current distributions. Alright? Okay. Okay. So we do that. Let's try to solve for the electric field and the magnetic field. So E, dalawang terms yung E natin, di ba? So E is actually negative gradient of V. Pero gradient of V, gradient of 0 is 0. Then the additional new term, the partial of A, partial of T, vector, vector. So this is 0. Kailangan mo na lang is time derivative ng A. Okay? Okay. So partial A, partial T is mu naught K over 4C Ct minus X Ct minus absolute value of X squared Z hat. Okay. So si X, wag muna tayo magpapanik kay X no paano ba derivative yan. Kasi hindi naman siya tatablan ng derivative with respect to time, di ba? Okay? So we have mu naught K. Tagus lang muna. So, and then, derivative nito with respect to time, bababa si 2. Pakopihin mo. Times yung derivative nito. Mag-0 lang yung derivative nito with respect to time. Then, derivative ng Ct gives out C. Okay? So, simplify mo mu naught A over 2. Cancel C. And then, Ct minus X Z hat. Okay? Kopihin mo lang yung direction. And then negative. Okay. So yung E, this is partial A, partial T. Therefore, yung E mo, negative lang na ito nakuha natin. Okay? So, same naman nakuha natin, no? And then, the curl of A is simple. Bale, ang kailangan mo lang ay malaman kung sino yung mga mag-0 and to-survive. Okay, tingnan natin yung A. Saan siya dependent? Sa X. And anong meron siyang direction? Z. Okay, so yung VZ lang yung mag-exist. VZ, ito walang VZ, so wala to. Wala yung Z hat component. Pwede lang magkaroon ay itong Y component and the X component. However, VZ has no Y component, so therefore this guy zeroes out. Therefore, ang maiiwan na lang is yung VZ derivative with respect to X. Okay? So, ayan. Naging negative derivative of X siya. Okay? So, let's do that. Ang gagawin mo, guys, pag meron kang value ng absolute value, huwag ka magpapanik. Well, pwede ka matakot pero huwag ka magpapanik, no? Gagawin mo, ihiwalay mo yung case niya para hindi ka mahirapan. Okay? So, you have your A as mu naught K for C. Mu naught K over 4C. Mu naught K over 4C. Then, let's get the things in the parentheses. C, T. Okay. And then C. C2 plus X squared. Ang gagawin mo, whenever X is positive, and then iwalay mo siya sa dalawang case. X is positive and X is negative. Okay? So yung mangyayari sa absolute value mo, matatanggal mo siya kapag in-split mo siya sa dalawang cases. Okay? Kapag X is positive, kukopyahin mo lang siya as is, and X is negative, maglalagay ka ng extra negative sign. Okay? Okay. Gets. So you have that, and then you try to differentiate it with X. Mas madali na siya ngayon, di ba? X, A, okay. So, mas madali mag-derivative ka kapag naka-piecewise. Nakita mo agad yung changes on both cases. So, bababa lang si 2, Ct minus X times C. Sir, saan po ulit nang galing yung V ko kanina? Anong V? Ito ba yung V na tinutukoy mo? Ito galing sa likod ng libro. Okay, hindi ko kabisado yung curl. Hindi ko kabisado yung curl, guys. Kaya kinokopya ko lagi ito sa likod ng libro. Okay? So, isipin nyo A yan. A. Okay. Sorry for the confusion. Ito ay example sa likod. Yung nasa cheat sheet na sa likod ng libro. Okay? Kasi hindi ko kabisado yung curl eh. So, A yan. Isipin nyo A. Sorry. Okay, continue tayo. So, derivative. Oops, ano ginagawa ko? So, tama naman. Ang mangyayari lang is meron kang negative sign. And then 2ct plus x, positive sign. Okay, so this is for x greater than 0, x less than 0. And if we simplify this, we'll obtain oops, may message. Okay. Okay na yung concern, sorry. Kinukuha lang natin yung curl ng A para sa B. Okay ba yan? Okay. So now we have to simplify this. Okay, so nangyayari, magiging short x. Pagsamahin mo na sila yun, u naught k over 2c. Tapos negative, positive, tama. ct minus x. Uwa. Okay, pinagsama ko na ulit sila. Tapos negative, positive kasi may negative sign pag positive siya. Then positive sign pag negative. Yung x. Okay, so nasa baba yung positive. And then sabi niya, negative yung mabubuhay. Negative derivative with respect to x. So we have an extra negative. So babaliktad lang din yung plus minus na ginawa ko. So you have this b. Okay? You have e, you have b. Then what's next is that kunin natin yung divergence with respect to e and divergence with respect to b. Okay? So yung divergence, tingnan natin, mag-survive lang yung divergence kapag meron kang component na depende rin dun sa component na yun. Okay? So pag sinabing may z-hat component ka, dapat meron kang z sa loob ng function mo. Otherwise, mag-zero ka, di ba? Kasi ang divergence ng some arbitrary function, v, is dx derivative with respect to x plus y respect to y dz respect to z. Okay? So kung wala siyang component niya do sa sarili niyang yun, maglalaho lang siya. And pansin naman natin na yung sa electric field mo, wala siyang z. Therefore, kapag kinuha mo yung divergence niyan, 0. Sa B naman, wala rin siyang y. Therefore, 0 din. Easy. Okay? Sa del cross E, ang kailangan mo, del cross E, kailangan mo yung partial with respect to time ng B. Negative nun. And then, simultaneously, pwede mong kunin yung curl ng E. Okay? Dapat mag-i-equal yung dalawang result na yun. Okay? Okay. So, yung partial ng derivative ng B with respect to, unahin natin to nasa baba, no? Yung derivative with respect to time lang. Okay? So, straightforward yung sa E, mawawala na yung X dahil independent of time yan. So, ito lang yung madederivative mo. So negative mu k c over 2. Makes sense. Okay? Yung derivative with respect to time ng b. Okay, punta tayo dito. Ganun lang din. Ct yung madiderivative mo lang. And then, okay, maglalaho yung x. Therefore, ang matitira na lang, kakancel yung c, mu naught k over 2, plus or minus. So, walang nangyari doon sa plus or minus. Okay? And then, kapag kinurl mo naman si e ngayon, okay, curl of e, so vz, hindi tingnan mo ulit. So, ito lang ulit yung magsasurvive. Ito yung magsasurvive. And then, kailangan mo lang i-tingnan yung mga signs, no? But in essence, if you're gonna do this, mawawala lang yung x, pero mabubuhay yung changes niya in sign. Okay, kasi ito ay absolute value. Okay? So, kapag positive may extra negative ka pa ulit. So, negative, negative, positive to. Tapos, kapag positive si x, negative to, mapapansin mo na yung kapag x greater than 0, negative yung sign mo. Okay, nalito ba? Gawin natin. Mu naught k. Okay, so E is equal to negative mu naught k. Nakalito pala yun. Sige, gawin na lang natin. Negative mu naught k over 2 ct minus x. So, gawin natin piecewise, sorry. So, kapag may absolute value, gagawin mo laging piecewise para hindi ka malito. Negative mu naught k 2 ct plus x. This is for x greater than 0, x less than 0. And then if you're gonna get the negative derivative of e with respect to x, okay, nakuha lang to sa curl, no? Pansin mo na ito ay mu naught k over 2, mu naught k over 2, kasi may negative sign na akong extra, so mawawala yung mga unang negative. And then partial derivative with respect to x, x ct minus x ct plus x. Okay, x greater than 0, x less than 0. Okay, straightforward na to derivative. Kita nyo na. So, nasa baba dapat si positive. Mas negative to kasi maubos siya. Matitira yung negative sign. Okay, we have that. So, tama naman na negative nasa taas, positive baba. And these guys are equal kapag negative nito. Tama? Kasi negative partial of b with respect to t. Yung del cross e, di ba? And similarly, if you're gonna do this with your b, the curl of b, so again, gagawin nyo lang, hihiwalay mo ulit yung mga x, then derivative mo siya. Okay, so ang kailangan mo ngayon ay partial of by with respect to x. Okay? So kaya z hat yung lumabas sa del cross b. Kasi ito lang yung mabubuhay. Kasi y component ito, then dependent on x. Okay, so you have that, and then makikita mo na yung ano yung right hand side ng del cross b? Del cross b is mu naught j, and then plus this guy. So this is 1 over c squared, tama? Sorry, ito pala. 1 over c squared partial of e with respect to t. 1 over c squared partial of e partial of e. Kunin natin yung partial of e, nakuha na natin, di ba? So, kung tingnan natin itong term na ito, 1 over c squared times, dikit natin itong partial of e with respect to t. So, that is negative mu naught k c over 2 J hat. And look at this. Magiging mu naught, negative mu naught K over 2C ito. Okay? And then look at this. Negative mu naught K over 2C na rin siya. Okay, therefore, 0 dapat tong mu naught J. Diba? Kasi dito pa lang sa second term, equal na sila. Okay? So therefore, paano natin malalaman yung charge? The charge is this guy sa number 1 and sa number 4 mo makikita. However, nakita natin na del dot E, the divergence of E is 0. Therefore, rho is equal to 0. And then, from here, nakita natin na yung displacement current lang yung may value. Therefore, J has to be 0. Okay? However, saan nagagaling yung Saan nagagaling yung mga bagay-bagay? Saan nagagaling yung mga fields? Burahin ko lang to. Saan siya nanggagaling? Pag tinignan mo yung fields mo, yung B natin, tingnan natin yung B. At this, guys. At the boundary, at the XY plane, at the boundary. So, B is actually 2-valued. U naught K over 2, C, CT, cancel C. Dalawa yung value niya. Okay? Ibig sabihin, tumatalon siya ng value when it comes to x is equal to 0. Weird, no? Parang, okay. And when that happens, ano ba nangyayari pag ganun? Kailan ba yung mangyayari? Mangyayari lang yun. Tingnan natin yung mga boundary conditions natin. Okay? Kung naaalala nyo, sa electric field, tumatalon din siya ng value kapag may nasasalubong siyang sigma, di ba? Kapag may nabangga kang sigma, tatalon dapat yung field mo by an amount of sigma over 2 epsilon. Okay? The same way, yung parallel components ng B mo, tatalon din siya by an amount KF cross N. Okay? So let's try to look at this. Tingnan natin yung talon na yan. Okay? Okay. So, since yung boundary natin is on X, lalagay natin na N hat is X hat. Okay. So, 1 over mu1. Pero wala tayong mga mu, so 1 over mu naught. B, 1, parallel. And minus 1 over mu naught. B, 2, parallel. This must be equal to K cross X hat. Nakalit yung cross tsaka X hat, no? Okay. We know na, alam natin yung B1 and B2. That would be, what am I doing? The values of B whenever X is less than 0 and X greater than 0. Okay? So yung una would be negative. Ano yung value? So, mu naught K T over C. Tama ba? KT. KT na lang pala. Wala na pala yung C. T over 2. Okay? And then, tapos, on the other side, yung yung disconnect niya would be positive naman. KT over 2. Okay, lagay natin direction, no? Sorry. Para tayo nalilito. Y hat yung direction. So this is both y hat. And then you cancel mu naught, you'd see that this is actually mu naught k. Ay, wala na pala mu naught. Diba yan? kt over 2 minus kt over 2. And this is k cross x hat. Okay. And sulat na natin yung sum nila. So this is just negative kt. Kasi 1 half plus 1 half. And this is k, capital K. Yung surface current cross x hat. Okay. Okay. So you have this. Mukhang nabaliktad ko, sorry guys. Nabaliktad ko ata yung B1 and B2. Well, either way, yung magnitude ganun pa rin naman. Dapat positive to. So, sorry. Ito ay yung other side. Tapos ito ay negative. Okay, so magpa-plus-plus sila. Yeah. Plus ito, minus-minus. Okay. So, plus dapat ito. So that yung K mo is KT that is flowing through Z hat. Okay? Z cross X. So that is what ay na coordinate system? X, Y, Z. Okay, so Z cross X gives you Y hat. So, ayan. So, malalaman mo na meron palang surface current. So, this is surface current na KT running on the XZ plane. YZ plane pala, sorry. YZ plane. Okay? Nakalito, no? Nakakalito yung mga directions. Okay, so you have that. So that is the only charge that is the only current that is present in the system. Okay, so walang J, walang rho. However, there is K. Okay, so ayun, yun lang. Surface current yung dumadaloy sa kanya to produce such configuration. Okay. Mostly, ang gagawin nyo sa chapters 8, 9, 10, Maxwell's equations. You're gonna have to check Maxwell's equations lagi. So, ayan. Heads up. Time derivative kayo. Minsan nakakalito. Minsan time derivative pala kayo. Nagagawa nyo. Space derivative. And so on and so forth. Okay? Now, itong next na ituturo ko is hindi kasali sa exam. Pero kasi parang nawawala yung train of thought if I wouldn't discuss this. Okay. Gauge transformation. Para gusto ko ito ikwento para alam nyo yung gauge transformation. Para hindi kayo magpapanik kung ano yung mga gauge transformations. Okay? Guys, naaalala nyo ba na kapag nagsosolve kayo ng V and A, you can always add something that wouldn't affect your electric field and magnetic field, di ba? So kapag sa electric field, kapag yung potential mo, negative gradient ng potential, nilagyan mo ng constant A, this wouldn't matter, di ba? Kasi di-destroy lang siya ng derivative. And sabihin natin sa A mo, naglagay ka ng some other constant. that is not time dependent. Therefore, wala rin yung pake. Okay? Wala rin yung pake. So, ganyan, yung pag-a-add natin ng constant, valid yan sa mga potential mo. So, scalar and the vector potential. However, we can choose them nicely para to our benefit. And when you do this addition and subtraction of anything, ang tinatawag doon ay gauge transformation. Okay? So sa A, pwede kang magdagdag ng amount ng gradient ng some function lambda. And then sa V, pwede kang magdagdag ng time derivative of that function lambda. Okay? So pag nasatisfy mo yan, yung dalawang yan, dapat pag imuisip ka ng lambda, dapat idadagdag mo kay AI gradient nun. And then kapag naisip mo si lambda, dapat yung time derivative yung lalagay mo dito. Okay? Okay. So, ayun yung gauge transformation. However, yung mga ginagawang gauge, ang tawag dito ay gauge. Okay? Yung ginagawang gauge, dapat useful para sa calculations mo. Okay? So, meron tayong ginawang dalawang gauge. Ito yung mga popular gauges. Okay? Mga popular gauge na idadagdag mo para ano na to yung advanced na nag-skip na dito sa part na to. Okay. Okay, so itong dalawang gauge na to, si Coulomb at si Lorentz gauge. Ito yung usual na gauge na ginagawa. So yung unang gauge natin, si Coulomb gauge, naaalala nyo ba to sa potential formulation natin? Somewhere here. I think sa scalar vectors, vector potential, I mean. Wait lang hanapin ko yung ano. Okay, 17. Okay, ito. Naalala nyo sa isang lesson natin, we forced the divergence of A to be 0. Okay? And kinonvince ko kayo nun na pwede nyo gawin yan. Okay? Para mapadali buhay nyo. So in essence, ayun yung Coulomb, yung ginagawa natin dito is a Coulomb gauge, okay, which tells you that doing that wouldn't affect your electric fields and magnetic fields at all. So you use this, nung ginawa natin ito, na-formulate natin yung mga magnetostatics, yung vector potential natin sa magnetostatics, and so on and so forth. Okay? Now, an amazing thing gagamitin natin is Lorentz gauge. Kapag ginawa natin si Lorentz gauge, ito yung prescription na gagawin mo. So you have the divergence of A to be this derivative. Okay? So you have the time derivative of the potential, tapos yung speed of light squared, 1 over c squared. Okay? So you have this Lorentz gauge. And yung effect nito, mapapadali niyo yung equations natin in a sense that we could write down the Maxwell's equations as like this. Okay? So itong pa-square na to, mukha siyang nag-error na bad trip ako dito sa symbol na to. Parang hindi siya nag-render na symbol. Kasi square lang siya. Nung may libro, siyempre nung undergrad ako, may libro ako nung electrodynamics ni Griffiths. Ano ba to? Ba't hindi nag-render yung symbol? Akala ko something else yan. So, square talaga siya, guys. So, ang tawag sa kanya, si D'Alembertian. Ito yung definition niya. Okay? Okay. So, ito ay tinatawag na inhomogeneous wave equations. And it looks nice, di ba? Na ito, ang sinisimplify nito would be ito. Okay? So when you do that substitution sa del dot A mo, so divergence ng A, things would simplify. This whole thing would simplify to this. And it's now very useful. Okay? Kasi wave equation lang ito. Para siyang Laplacian. Okay? In a sense. So may general na solution for that and so on and so forth, pero ayun, hindi naman ito kasali. Gusto ko lang na okay, hindi yung mga problema nating mahirap yung math, napasimple niya. sa paggamit ng gauge transformation. Okay. Now we're going back to the problem. Ang problem natin, anong field kapag meron kang charge? Okay, and current. So, ayun yung kailangan natin ngayon. However, things are now moving. So, mas komplikado yung mga bagay-bagay. Kapag may nag-message sa yung kaibigan mo, di ba nakikita nyo kung kailan niya sinend? Okay. Pare, may kailangan siya yung kaibigan mo, may kailangan siya may craving siya nung t is equal to 0 na pizza. Kaso na-view mo siya ng 100 seconds, 100 days mo after na siya nabasa. So, ang craving niya pa rin ba pizza? Hindi na, di ba? Hindi na, di ba? Hindi na pizza yung kailangan niya. Okay? So, in a sense, ganito rin yung problema natin with when it comes to a moving charge. Okay? So, when you're this person and some charges move from here to here, so A, B. Kuwari nandito siya sa A at some time, at the past, gumalaw na siya ngayon dito. Okay, gumalaw na siya dito ngayon. However, yung news sa'yo, hindi pa nakakarating. So, this has to travel some distance before it makes a contact to you. So, pagdating sa'yo yung news na yan, nandito na yung charge niya yun. Okay? So, hindi mo naman to kailangan. Yung kailangan mo yung information na dating nangyari, yung past na nangyari. Okay? In a sense, yung kailangan mo malaman is yung t is equal to 0 na craving niya, which is yung pizza. Kasi nagta-travel yung news sa'yo by the speed of light. So, hindi lahat to instantaneous, no? So, nung mga unang chapters natin, we have assumed na nothing is moving. So, we didn't care about kung anong oras siya darating sa atin at all. Okay? So, kapag merong may charge configuration sa moon na gumalaw, instantaneously, hindi natin mararamdaman yun. The news has to travel to us at the speed of light. Okay. So, ayun. Ang kailangan natin is kung titingnan natin yung past niya. Okay? Kuha ba yan? Kuha ba yan? Okay. Okay. So, we have this dating model natin. Ito yung Laplacian ng V. Give you the charge distribution, and then the Laplacian of this vector potential give you the charge. And it reads off as this before and as this before. Okay? So, kuha pa naman natin to na ayan siya. However, if we're gonna add the time component, magde-define tayo ng retarded time. So, isipin nyo as past time siya. Pero kasi pangit past time, no? Parang pampalipas oras yung pangalan niya. So, tinawag na lang siya retarded time. Kaya TR. Retarded time. Okay? So, the retarded time gives you the time in the past. So, this is the time in the present. Then, babawasan mo yun kung gano'ng kalayo yung tin-travel niya papunta sa'yo. Okay? So, this is the distance from the charge to you. And this is the speed of light. Therefore, dividing those two will give you the time it takes for that news to travel to you. Okay? So, ang kailangan mo makita is yung past. Yung past niya. Hindi ba mas di? Ako, ewan ko rin kung ano naisip ng mga ng mga scientists natin. Bakit tinawag nilang retarded? Okay. Pwede namang delayed time. Ganun. Delayed time. Past time. Anyway, sige. Gamitin natin kung ano yung nasa libro. Retarded time. Okay. Then, sinabi natin na, okay, hindi ko na to ipo-prove, but we can always consult your book on how these guys are proven. Okay. So basically, ang changes lang na mangyayari kapag meron kang retarded time, is that titingnan mo ngayon yung charge distribution mo at that retarded time and yung current mo at that time. Okay? So, yun lang yung bago with your potential and your vector potential. Sir, ba't hindi na lang dumiretso tayo sa E? Papakirap pa tayo dyan. 1/4 pi epsilon naught r squared, r hat, r hat, then rho, r prime, er. Something like that. Di ko nakabisado yung ano natin. Yung, parang ganyan, di ba? R squared dependence, tas vector siya, etc. etc. So, bakit sir hindi na lang tayo dumiretso sa electric field? Tapos tingnan natin yung charge distribution at the retarded time. It turns out na hindi itong electric field mo na yan, hindi siya mag-fit doon sa D'Alembertian mo, sa inhomogeneous wave equation. And and fitting in these equations would tell you that you fit to the Maxwell's equations. So kung dito pa lang hindi ka na satisfied, therefore mali ka. Hindi ka pwede sa Maxwell's equation. Wala ka sa electrodynamics. However, this guys, itong V and yung A mo, it fits nicely to the D'Alembertian here. And therefore, satisfies the Maxwell's equations. So, ayun yung proof niya dun sa libro nyo na ipa-plug in mo to dun sa mga wave equations mo. And dapat ma-produce niya yung tamang Laplacians. These guys. Okay? Okay. So, anong bago? Anong bago dito? Parang wala namang bago dito sa ginagawa natin. Medyo mahirap na to ngayon, guys. Mahirap na to. So, babalik tayo ngayon sa normal integration natin. Titigil muna tayo sa mga Gauss's law, Ampere's law, and babalikan natin itong pag-integrate ng ganito. Which is mahirap, pero kailangan natin gawin. Okay? Ngayon, ang i-consider mo dito is at some point in time, only a few of your charges affect you. Okay? So, ayun yung kailangan nyo i-keep in mind. At some point in time, hindi mo lahat ma-feel. Okay? Kapag dapat sinet mo yung t is equal to infinity, dapat mararamdaman mo yung normal na fields, which is normal na potentials, which are these guys. Okay? So, you have to consider that 2 points. Okay? So, now let's try an example. Okay? May infinite straight wire tayo na merong current na 0 kapag t is less than 0 and t kapag mas greater than 0 ay not yung lalabas. So, ibig sabihin nun, binuksan mo yung current at t is equal to 0. Okay? So, hanapin natin daw ngayon yung electric and magnetic fields. Okay, looks simple, di ba? Pero hindi. Dito madali, hindi nakakatawa. Okay, guys, ang first thing na kailangan nyo isipin, yung current dito, yung current sa electrodynamics does not flow like water. Okay? Pag binuksan yung current, lahat yan dadaloy agad-agad. Okay? So, does that violate the causality of time? So, hindi na may violate yun kasi pinapagana mo lahat yung current dun sa buong wire mo. Okay? So, itong current dito, nawala. Ang current mo dito is independent of this part, and so on and so forth. So, pwede mo silang i-activate lahat for your current to be produced. So, no undergrad ako, iniisip ko, parang ang weird naman itong problem na to. Kasi, di ba kung isipin mo yung current, dapat at t is equal to 0, nandito pa lang siya. And t is equal to infinity, nandun na siya. So, mali yung thinking na yun. So, I learned that the hard way. Okay? So, namali pa ako sa mga exam. Okay, wait lang guys, ubusin ko lang yung kape ko. Okay, so we have that. Ano nang gagawin natin ngayon? Kailangan mong mangyari, anong kailangan mong makuha is syempre, yung binigay lang sa'yo is current lang, di ba? Ang direkta mo makuha is yung vector potential. Therefore, we need to get the potential A. Sulat lang natin, RT Then that is mu naught 4 pi. And then J, the current, R, PR, B tau, R. Okay, so ayun yung kailangan natin. So kailangan mo makuha yung current mo at the retarded time. Okay. However, yung retarded, zero to kapag yung time mo less than 0, di ba? So, ang kailangan mo lang is, at the moment na mag-t is equal to 0, dun ka magkakaroon ng value. So, dun mo i-start yung integral mo. Tama ba? Kuha lahat? Kuha. Okay? Okay. Okay. In essence, you need to solve for this. Mu naught, I naught, 4 pi, dz. Parang ang simple lang, sir. Okay. So, lumabas lang yung current mo. Kasi constant lang to at t is equal to 0. Okay? At t is equal to 0. Alright, so we have this. However, sabi ko nga sa inyo na kailangan mo na i-consider kung sino yung makaka-apekto sa'yo at some point in time. Okay. T is equal to 0, nasaan yung news? Okay. Meron kang current na pa ganyan, meron kang current na ganyan, so on and so forth. Okay. At T is equal to 0, nandito pa lang yung news. Hindi pa siya umaabot sa P. Therefore, ang makukuha mong A at T is equal to 0 would give you an A is equal to 0 kasi wala kang ini-integrate. Walang nagko-contribute sa'yo at T is equal to 0. Okay. What is the shortest path from the wire to point P? Okay. What is the shortest path? Jello, nandiyan ka ba?
Ay, sorry po sir. Ano nga po ulit yun, sir?
Ano yung pinakamaikling path papunta kay P mula sa wire?
Hindi ko po sure kung sagot po yung...
Ano yung nafe-feel mong sagot?
Yung S.
Okay, tama. Yung S yung pinakamaikli niyang dadaanan, tama, di ba? Kasi pag dumaan siya sa R, that would take a much longer time, di ba? Kasi mas mahaba yung path na yan. So the shortest path for the news to go through is through S. Okay, and what is that time? So, C times T must be equal to S. Okay, velocity times time. So, magka-cancel yung time component. Therefore, for T is equal to S over C, the news comes to you. Okay, so the first instant na magkakaroon ng value yung A would be at T is equal to S over C. So the time less than S over C gives you nothing. Okay? And then kapag lumagpas na tayo sa S over C, sabihin natin na S over C, what happens? Itong part na to would contribute. And pag tinaasan mo pa kunyari yung time mo, this would contribute, and so on hanggang mabuo mo yung buong current mo. So at T equals infinity, dapat makuha natin yung magnetic and electric field natin na given yung infinite straight wire. So dapat ayun yung end goal natin, okay? So we go back to our system and try to guess which part of dz will contribute as a function of time. Okay? So we know at meron tayong value na ito, nakikita niyo naman to S over C. Ayun yung unang value. So ang magko-contribute lang doon is Z is equal to 0. Okay? For this part. Okay? Kasi ito yung Z is equal to 0. Assume natin yan. Okay? So, kailangan natin makakuha yung bounds ng integral natin, no? Para makita yung mga nagko-contribute. Okay? Okay. So next is at some arbitrary time that is greater than S over C. Sabihin natin nandito yung point na kino-consider natin. Kasi 'di ba ito yung unang darating na news. And then itong dalawa yung magbibigay ng susunod na news. Kunyari, okay, kuwari discrete lang to. So what is this distance from that point to this point? Okay, so that distance is given by gawin natin yung Pythagorean theorem, Ct squared, okay? And then z squared, this height, z squared plus s squared. Tama ba? Diba? Pythagorean lang yan. Okay? So yung hypotenuse is Ct squared, okay? So yung t mo, arbitrary yan, kung anong time siya, Okay? And then, hanapin natin yung z, kung anong value ng z at this configuration. So, isolate mo lang. Ct squared minus s squared must be equal to z squared. Therefore, z has to be square root ng ct squared minus s squared. Okay? And this makes sense no na yung t is equal to s over c would give you 0. Tingnan nyo pag pinlagin mo yung s over c dyan, magiging s squared lang to minus s squared. So mag-0. Okay, so this is the time start natin. And at some arbitrary time, the distance na kailangan i-cover nung light mo is this guy, and we isolated z. Okay. So we now have your, sabihin natin 0 to, and then the upper bound would be ct squared minus s squared. Okay, wait sir, akala ko ba, sir, lagi pong magsisimula sa point na pinakamalapit sa t. Yes. Okay, yes. Kasi dun unang darating yung news. Okay? Okay, sir, sabi mo, yung kabilang part din dapat may nangyayari din, di ba? Kasi itong time nito or yung distance nito would be the same distance as this green one. Okay? Therefore, dapat yung integral bounds ko dapat, sir, dapat negative ct squared s squared. Make sense, di ba? From below plus to above. Dapat ganito dapat yung integral bounds ko, sir. Yes, dapat ganyan. And makikita natin yun sa math natin. Di ba z squared to dapat, tas in-square root mo. Ang sinabi ko pag ganun, magiging absolute value dapat. So, dapat plus or minus to. Okay? So, dapat, dapat ito talaga. However, pwede natin simplihan yung buhay natin dahil same lang yung contribution nung below at nung above. Okay? We just have to multiply this by 2. To accommodate the other part. Okay? Okay. Now, R, madali lang tong R. Guys, alam nyo tong R? Square root ng s squared plus z squared. So, you have this integral. Yung a mo, magiging ganito, mu naught I naught over 4 pi. So, ayun yung mga pinactor out lang natin na constant. Okay? And then, the direction is z din kasi pino-follow ni A si J. Okay? And then, sabi ko nga, multiply na lang natin ng 2 kasi same lang yung contribution ng below at ng above. Symmetry lang. Okay. So, we have to integrate dz up to this point. Okay? Okay. So, you have this integral and this is trig sub. Z is equal to S tangent and so forth and so on and so forth. You do that. Hindi na natin gagawin dahil that is way beyond our scope. I mean, way back before our scope. Okay? Ang makukuha mong integral would be, guys, pag sa exam, minsan may mga bagay tayo na okay lang sa akin na kahit hindi nyo na i-detail. Kailangan nyo lang isabihin na, ito yung trig sub nito. Tapos, ang i-integrate ko, sir, ay d theta over secant theta. secant theta. Okay, pwede nyo na sa akin ibigay yung ano nito, yung identity nito. Kasi, di ba, may mga identity naman na to. Okay? So, mga ganyang bagay, pwede nyo na yan hindi i-solve. You just show me how you get there. Okay? Tulad nito, maglalat kayo dapat ng S tangent theta and so on and so forth. Then you'll arrive with something like this. And if you integrate this, mapuproduce mo to. That's okay for me. Okay sa akin yun. Para hindi kayo, hindi masyadong mahaba yung solution. Okay? Mga ganong bagay. Okay na yan. And then, ito, plug in mo yung integral bounds mo sa Z. So you have this, produce mo to. So this is your vector potential. Now, straightforward na yung pag-compute ng electric field and the magnetic field. Okay, guys? So, ang gagawin mo na lang, derivative with respect to time, and then the curl of A, which is easy kasi isang term lang yung mabubuhay. Kasi ito ay Z component lang and with respect to S. So, you have this form. Okay? So, you obtain this. Madali lang to. Madali lang din yan. You can do this on your own time. And we find out we have this guy. Okay, now, this is where the magic occurs. Diba? Sabi natin, at t is equal to infinity, dapat stationary na yung system mo, di ba? Kasi at t is equal to 0 ka lang naman nagkaroon ng changes. So, dapat t is equal to infinity. Dapat makukuha natin mga previous result natin. Okay, plug in natin ngayon yung t is equal to infinity dito, guys. Pag pinlog in mo to doon, mag-i-infinity yung denominator, 0. As expected, wala tayong charge. Therefore, dapat mag-vanish yung electric field natin at some time. Okay? Okay. Now, medyo mahirap mag-plug in ng t is equal to infinity dito. So, ayusin natin ng onte. I naught, 2 pi s. And then ct divided by, factor out ko yung t. So, mga t squared, okay na. C squared minus s squared over t squared. Kuha ba yun? At pinactor out ko yung t squared dito. So, tatawalan siya ng square root mo. So, makakalabas siya ng square root. Then you have this. So, you have this, have that. And then I plug in now. Madali na ako makakapag-plug in ng t is equal to infinity. Pag pinlog in ko yung t is equal to infinity ko dito, yan. So, this guy zeroes out. And you're left with c over square root of c squared. So, that cancels out also. And what, ano naiwan sa atin? Familiar to, di ba, guys? B is equal to okay? Okay, di ba? Amazing, di ba? Mu naught I naught 2 pi s. Ampere's law ng infinite straight wire. Di ba? Ayun yung lalabas. Okay. So, kaya natin inuna yung magnetostatics tsaka electrostatics kasi doon madali buhay natin. Dito, hindi madali buhay natin dito. Okay? So, ayan. Depende sa time ngayon yung mga electric field mo and magnetic field mo. Okay. Now, ano sabi natin? Ito yung potential na mga retarded potentials and retarded potentials. Scalar and vector. Bakit hindi tayo nag-proceed na lang dito sa E? Ba't hindi na lang natin hanapin itong E and rectang B? Okay? So, to find that, hanapin natin yung E and B. Ano gagawin mo dito? The derivative mo to depending on sa E mo. Di ba ang E ay negative gradient ng V plus partial A, partial T. Okay? And then B is just the curl of A. Okay. So, when you plug in these boys here, you actually get something that is not very straightforward, not very intuitive. Okay, so these are called the Jeffy-Menkos equation. And look, di ba? May rho na retarded time, may change in rho with respect to the retarded time, and the change in the current with respect to the retarded time. Okay, sa B, makuha mo yung J at the retarded time, and the change in J with respect to time with respect to the retarded time. Okay, so kung ano yung itsura niya in the past, ay ilalagay mo. So, ang sinabi natin, ba't hindi na lang ganito? Kasi, kita mo nga, yung Jeffy-Menkos equation ay yun yung nagsasatisfy ng mga wave equation mo galing sa Maxwell's equation. And is this useful, guys? Is this useful? Tignan mo nga. Meron kang tatlong integral. Yung isang integral nga na sobrang tagal na natin ginagawa, di ba? Okay. Wait lang guys, wait lang. Okay, sorry guys, may kumatok. Okay, so isang integral pa nga lang, mahirap na. And then, tingnan nyo yung mga integral na to. Kukunin mo pa yung change in rho, kukunin mo pa yung change in j. Ito may vector, r squared, r. So complicated, guys. So hindi to useful. Hindi to useful, guys. Hindi nyo gagamitin to ever, probably in your life. Tapos dito, dalawang curl yung i-manage mo. Isa r squared pa. Okay, so this is not very useful. Ang maganda lang, at dito ka na lang mag-stay. So, sa potential mo, kunin mo na lang derivative later on. Okay. We could have solved this in terms of the Jefferman-Cos equation, but that would be very, very, very complicated. So, mas madali na, derivative mo na lang sila. Di ba? Mas madali mag-derivative kaysa mag-integrate. Now, we have the right now to do meron na tayong right to do the potential of a moving charge. Hindi natin ito kino-consider pa kasi alam natin, yung mga previous chapters, given ka na ng electric field and so on. But with the potential formulation and the idea of retarded time, pwede na natin computein yung moving point charge. Okay. So ito yung potential natin na may retarded time. And kung isipin mo, sir, di ba parang ganito lang dapat yung lalabas dyan? I-compute mo na lang yung R na with respect to its past position, di ba? Kasi Q lang naman yung Q lang naman yung charge mo, di ba, sir? So dapat ayun lang yung mag-give off. Apparently, it's not. Okay? Kasi kapag gumagalaw yung isang bagay, meron siyang sort of after image. Kuwari, meron ka yung mga, kuwari may ninja ka, si Naruto. Okay, kuwari tumatakbo siya. Meron siyang sort of after image dito. Okay? So, yung mga naiiwan na after image niya, mayroong contribution doon. Okay? So, kung wari, merong tao, may superhero, si The Flash. Okay, si The Flash. Okay. Si The Flash yan. Okay, si The Flash. Sumigaw siya ng hello. And then pumunta siya sa tabi mo, nagsalita siya ng hello din. Ilan yung hello na maririnig mo? Dalawa, di ba? Kasi paparating pa lang sa iyo isa, tapos tinabihan ka niya. So maririnig mo yung pangalawa. Okay, so may ganong factor. Okay. Kapag may in motion yung particle mo. So may ginigive off siya na extra terms, elongation term. So that is something purely geometrical, and it turns out you can just simplify this whole thing. Tatablan lang talaga ng integration mo dyan. Sabi ko nga is yung shape ng object. So pag yung integration with respect to charge, mag-iiba yun, and you can have this term to replace this integral. Okay. So how did we end up with this? Okay. So nag-explain si Griffiths kung paano mo siya iintindihin. Okay. So let's try some thought process. So suppose meron kang in the past, you have a train. May train ka. Okay. So isipin nyo train yan, guys. Okay. And then drawing natin yung front end ng train. Okay. And lagyan lang natin ng markers. Okay, wag muna pala. Okay, so, okay, ngayon, nandito ka sa harap. Okay, pinapanood mo yung train. Okay, hindi ka mababangga, ha? Huwag niyo isipin yun. Tinitingnan mo yung train. So, ayan, kaya yung mata mo. And you look at the end part ng train. Okay? So, when you look at that end part, yung end part na yan, may image siya, di ba? May image. And that image goes to you as a form of light. That. Okay, so yung green light yan, ayun yung image nung puwet nung train. Okay? So, at the moment na ginib off niya yung light na yan, it travels to you at the speed of light. So, may onting delay, no? Kung medyo malayo-layo yung train. And then, however, kapag umandar na yung light na yan, umaandar din yung train at the velocity v. Umaandar din yung train at the velocity v. So, by the time that the light reaches to you, so, ulit tayo ng mata. Okay. Present. Dali natin present. Ang pangit pala ng drawing. I-atras ko ng onti to, guys, ha? I-atras ko lang ng onti. For the sake of argument. Okay. So, nag-give off siya ng light. Tinang natin ng marker dito. This one. Okay? So, by the time that it reaches to you, the light reaches to you, the train has traveled already. Okay? So, travel yung train. Travel na siya. Okay? By a distance this much. Ay, nawala. Anong nawala? So, by this much. Okay? So, sabihin natin yung distance natin travel ng light ay some L prime. Okay. And suppose na tumayo ka doon sa harapan ng train. Okay. At nakaposition ka on that train. And then the length of that train is this. Okay. So, what is the time traveled from here? From here to here. The distance, the time that is required for the train to travel at that distance, the velocity v, is L prime minus L divided by its velocity. Tama? Distance over velocity is time. So, ito yung tinravel nung, ito yung time traveled nung, yung train by this much. Okay? However, in that time, nakapag-travel na yung light mo, from this point to this point, and that length is L prime. So, L prime divided by its velocity, C. Therefore, these guys are equal. So, L prime over C must be equal to L prime minus L V. And if you simplify this, you obtain this much. Okay? Okay, anong ibig sabihin nitong mga bagay na to? Okay. Napansin nyo, yung image ng puwet pa lang niya, dumating sa'yo at the present, pero mas malapit na sa'yo yung trend ngayon. Okay. So, anong image na makikita mo? Nandito pa yung puwet niya. Diba? Nandito pa yung puwet ng trend, pero nandun na sa harapan mo yung harap ng trend. So, ibig sabihin, humahaba yung trend kapag masyado siyang mabilis, tapos papunta sa'yo. In the same way, kapag papalayo siya sa'yo, you'd see that, mag-switch ka ng terms, you'd see that mas maikli yung trend. Okay? Kasi dahil delay yung nakakarating sa'yo na information. So you have that. In that process, also, kapag binago mo naman yung point of view mo, wari dito ka na tumingin at some angle, theta, you'd see that the time required is now L cosine theta, and the apparent length of the train is this. Okay, apparent length to, di ba? Apparent na length ng train. Kasi nakita mo siya, buo siyang ganyan. Pero in reality, ganito lang talaga siya kahaba. So, whenever a thing moves, okay, iiba yung apparent length niya. Well, kapag papalapit sa'yo, kapag papalayo sa'yo. Okay, so you have this. Now, we can generalize this to accommodate different directions by putting v as a vector, then yung r hat kung saan siya papunta, or kung saan ka nakatingin. Diba? Okay? Kung yung r hat ay nasa v hat direction din, ito yung nangyayari. Okay? R hat is equal to v hat direction. Therefore, ito yung mangyayari. Pero kapag at some angle ka, magkakaroon ka ng cosine. Okay? So you have this part. And therefore, for in general, your volume, kasi length lang to, no? Kapag may nag-expand na thing, tapos papunta sa'yo, the apparent volume is given by this. Okay? So kung di kayo convinced sa kwento ko, no? Basahin nyo na lang yung explanation niya. Okay? And then, whenever we have some particle trajectory, W, okay, so W is a position of Q at time T, then we can actually get, di ba yung separation vector, guys? The separation vector is this distance, the distance of the charge to the point of interest. So that is R minus W. Siyempre, kung saan siya in the past. WTR siya. Okay, so this is a vector, this is a vector, this is a vector. And this, itong separation vector na yan, equal yan sa tatravel nung news mo in time. So, equal yan sa C, T minus TR. Okay, so the retarded time minus the present time minus the retarded time. So, ayun yung itatravel nung news para makarating sa'yo. Okay? And then, itong absolute value denotes that this is just positive. Okay, kasi kinukuha mo lang yung R. Okay. Kasi hindi naman nagne-negative yung speed of light. And you're not looking at the future. Okay. Wala lang. So you have this. Okay. You have this. Okay, and then may ano dito, merong footnote si Griffiths na at only one time, isa lang yung makakadating sa'yo na information. Okay? Unless na lang yung particle mo travels at the speed of light, which of course violates physics, isa lang yung darating sa'yo na information at a certain point in time. Okay? However, hindi siya the same sa case ng sa case ng listening. Sabi ko nga sa inyo, kung more than the speed of sound yung travel, yung emitter ng sound, makakarating sa'yo yung dalawang sound. Okay? Kasi mababa yung speed of sound. However, yung speed of light is the maximum. Therefore, hanggang dun lang yung pwedeng hindi pwedeng mag-travel yung mga particles mo at the speed of light. So therefore, isa lang yung darating na message sa'yo in every point in time. Okay? Okay. So that's for single particle lang. Okay? Now kung i-simplify natin yung potential formulation mo dito, plug in na natin yung nalalaman natin, which is this. You'll obtain this guy. This is the potential of your this is the potential for a point charge, and this is the vector potential for a point charge. Okay? So, sinulat lang siya in terms of the scalar potential, which is nice. No? Isa na lang ikukunin na. Okay? Now, ito ay si Leonard Wishart. Leonard. French, tas German. Okay. So, yan. Okay. Now, paano makukuha yung field? Di ba? Madali na lang yung field. Kunin mo yung derivative na itong mga to. So, if you're gonna do that, hindi na natin gagawin to. Nasa libro na siya. Basically, meron kang partial with respect to time and gradient. Yung gradient mo, however, magiging, say kunyari, x lang, magiging ganito siya. The derivative with respect to tr and with respect to tr, with respect to x. Okay? Susundan nyo yung libro. Okay, bakit mo dinederivative yung time? Kasi yung TR, dinefine natin siya as some position. Diba yung TR is present time minus R over C. So, pwede mo siya i-derivative with respect to the space. Okay, so, ayun lang yung gagawin mo sa derivation from potentials to the fields. Okay, so this is the potential of this is the electric field for a moving charge. And you have two terms, the velocity field and the radiation field. Okay, so whenever your particle, the charge, is accelerating, may pinaproduce siyang radiation, which is the topic of chapter 11. Okay, so yung velocity field is U. Ito yung definition ng U. Then V is defined as the derivative of the trajectory. Position tong W, guys. And then yung A is defined as yung acceleration, derivative ng V. Tapos kung ililipat mo pa yung W doon, double derivative niya at the retarded time. So yung mga velocity mo and acceleration, that is on the retarded time. Okay? So this is the electric field and this is the magnetic field. Ang ganda ng magnetic field, no? Kino-cross product mo lang yung E. And then the force, lastly. So this is the entirety of electrodynamics, guys. Kung describe to sa unang chapter, tapos na tayo sa lahat ng kailangan natin gawin. Okay, so F is equal to Q E plus V cross B. Okay? So ano yung V dito? Ito yung velocity ng Q. Okay, so this is the entirety of electrodynamics. How would you define the force? This is the force. Okay, gamitin ba natin sa exam to? Hindi natin alam. Hindi pa natin alam. Okay, for a constant, lastly na lang to, mabilis na lang. This is for the fourth exam na, no, guys. Huwag na masyado isipin ngayon. Mahalaga yung third exam. If we're gonna consider, may example sa libro na constant yung velocity ng particle, the charge. So, 0 yung A, you'd obtain this. Okay. And what does this look like? This guy. Okay. So, may na-emit siya na electric field na ganyan. Okay, intuitive lang. Hindi siya intuitive pala. Isipin nyo lang, ba't mahina yung electric field sa direction of motion? Okay, so maalala nyo, pag meron kang charge na gumaganyan, meron kang magnetic field na ganito, then meron kang Faraday's law, na merong magnetic field na pa ganun, ay merong current na gumaganyan, tapos i-reduce niyo yung electric field. Okay, kaya mahina electric field sa direction of motion. Okay? Kasi ito, nag-i-induce siya ng magnetic field, and that magnetic field induces an electric field, and so on and so forth. Kaya mahina yung electric field niya at the direction of motion. And nicely enough, kunin niyo yung curl nito, kunin niyo yung cross product niya with respect to the direction of R hat, curly R hat, and it would look like this. Ang ganda, di ba? Okay. So kapag line charge na siya, kapag line current na siya, mabubuo mo siya yung ganyan. Yung usual alam natin. Okay. Okay. Nag-rotate siya around kapag buo na yung current niya. Pero syempre, ito ay charge. Kaya ganyan yung itsura nung yung field niya. Ganda, di ba? Okay. So, that's it for today, class. Thank you for staying 6 minutes tayong delayed. It's lagpas, sorry. Meron pa pala, sorry. Itong concept ng retarded time, you can have disproved this THIS. Disprove on the other one, TA, T advanced time. T plus and you'd see that the theory fits well. Pero alam naman natin that the future cannot affect us. Only the past can affect us. So it violates the causality of time. Hindi tayo pwede affectan ng mga potentials happening in the future. Okay? Pero it's nice na nag-fit siya sa proof nito. Advanced time. Okay. Anyway, yun lang. Any questions? Any questions? Oh. Sir, ano po final schedule ng exam? Ito, nag-message na si Sir Baguno. Wed na tayo mag-exam. Wednesday na mag-exam. Okay? So, good luck. Good luck on your exam. Sir, question po about chapter 7. Meron ka pong changing current, changing B field. Sir, kasama po ba yung topic today sa exam on Wednesday? No. Ang exam nyo lang ay 7 to 9. Chapter 7 to 9. And then chapter 7 ako magbibigay. Chapter 8 and 9 si Sir Baguno. Okay, so ito may mga questions na lang. So iba, dismissed na kung gusto nyo lang mag-leave. And sinasagot ko lang yung mga questions ngayon. So, okay. Question po, about chapter 7. Kapag meron ka pong changing current, changing B field, pero wala namang nearby loop na pag-iindusan ng EMF to counter the flux, meron pa rin po bang back EMF yung source current? Yes, dahil dun sa displacement current. Okay? So may imaginary currents ka na nagpo-produce ng counteraction. Okay. So iniisip niya guys, di ba kuwari may bumukas bigla na magnetic field. Tapos wala namang loop. So ano i-indusan mo? Di ba parang ganun yung tanong, di ba? Wala namang loop pero bumukas bigla yung magnetic field mo. May mai-induce pa rin, yes. May mai-induce pa rin na electric field. Tapos yung induced electric field na yun, marirelate mo sa displacement current, and that current would produce a magnetic field to counter that yung pag-open ng field. Okay, so yung mga ganung bagay, kaya siya pag tinignan mo sa laboratory, meron siyang delay. Okay? Kunyari, binuksan mo yung magnetic field from 0 to B naught, hindi siya at an instantaneously, mapupunta agad siya from 0 to B naught. So, meron siyang time delay na onte. Kasi, kina-counter ng mga induction yung magnetic field niya. And it's a manifestation of Lenz's law. Amazing. Okay, any more questions? So may ganun, no? May imaginary current. Gusto ko siyang tawagin imaginary current kasi hindi mo siya nakikita. Pero may current. Yes. Yung current nga lang na to, hindi niya sinusunod yung Ohm's law. Kasi, ayun nga, displacement current siya. Galing lang siya sa changing electric field. Okay. So, anything else? Kung wala na or kung meron, send nyo lang sa Canvas. Class dismiss na tayo para makapag-dinner na tayo lahat. And enjoy the weekend, of course. Okay. Have a nice weekend, guys.